Boyle's Law. So Boyle stated that the pressure exerted by a given mass of gas at a constant temperature is inversely proportional to the volume of gas. In other words, volume is inversely proportional to pressure. So as volume increases, pressure decreases. As pressure increases, volume decreases. We can put this into a formula with V equals K divided by P, where K is a constant, so PV equals K. An easier way to look at this is the formula P1V1 equals P2V2, where V1 is the volume at pressure 1 and V2 is the new volume at pressure 2. So you can see here using a plunger, when volume is decreased, pressure increases. And here, when volume is increased, pressure decreases. They are inversely proportional. As one increases, the other one decreases. So here's a question. A perfectly elastic balloon has a volume of 1.2 litres at a pressure of 750 millimetres mercury. Assuming the temperature remains constant, which means we can use Boyle's Law, what temperature will the balloon occupy if the pressure is reduced to 620 millimetres mercury? Read it like a book. A perfectly elastic balloon has a volume of 1.2 litres at a pressure of 750 millimetres mercury. So P1 is 750 millimetres mercury and V1 is 1.2 litres. Assuming the temperature remains constant, what volume will the balloon occupy if the pressure is reduced to 620 millimetres mercury? P2 is 620 millimetres mercury, and volume is what we're trying to find out. So we put those into the equation. P1V1 equals P2V2, and we just plug those values in. We can manipulate the formula around. If we divide both sides by P2, bring P2 around to this side, and now values in. So I've got 750 times 1.2 divided by 620, and I get an answer of 1.5 litres. It's important to point out too, because this is a ratio question, it doesn't matter what units you have volume in or pressure in, as long as they're the same on both sides of this equation. So if P1's in millimetres mercury, P2 must also be in millimetres mercury. The same as if volume's in litres, it must be in litres on the other side. So here's a question for you to have a go at. A certain mass of gas was sealed in a cylinder with a movable piston. At a pressure of 10 kilopascals, it occupied 2 litres. If it were allowed to expand until its volume was 10 litres, what would the final gas pressure be? So the first thing to look at with a question like this is the data that's presented. So here we have P1 being 10 kilopascals, V1 being 2 litres, and V2 being 10 litres. And what we're trying to find out is the final gas pressure, which will be P2. So we use the formula P1V1 equals P2V2. We rearrange the formula to solve for P2. So it'll be 10 times 2 divided by 10, which equals 2.0 kilopascals. It'll be in the same unit that the pressure was in the question.